So for my topic, I had 2.6, which is multiplication of rational numbers and expressions. So I said if you think about A over B times C over D, essentially that is the same as A times C over B divided by D. And this can be written in lowest terms. The numerator and denominator do not need to share any kind of common factors. So for an example, I said 1 1/2 times 2 3/4 can be turned into a fraction, and that will equal 3/2 times 11/4, which equals 33/8. I took the 3 times 11 over 2 times 4, and I got 33 over 8, and that can be put back into a mixed fraction, which is 4 1/8. So then for my word problem, I said that Sally brought 80 tomatoes to a farmer's market and sold 3/4 of them. And of the tomatoes she did not sell, she gave 2/5 to a local food pantry. So how many tomatoes did she give to the food pantry? I said that there were 1/4 of the tomatoes left. So I take 1/4 times the total amount, which is 80 over 1, and I got 80 over 4, which equaled 20 tomatoes. And then I took 2/5 of them that went to the food pantry. So 2 over 5 times 20 over 1, and I got 40 over 5, which equals 8 tomatoes. And 8 of them went to the food pantry out of the 80. Then a few rules to mention. When you multiply an even number of negative quantities, you get a positive number. And when you multiply an odd number of negative quantities, you get a negative number. So I said negative A over B is the same as A over negative B, which is also the same as negative of A over B. Then I did a few examples. So examples with variables, I decided to use a to the third power times b to the negative second power divided by b times c. I multiplied that, negative a to the sixth times c to the seventh over b to the fourth times c to the third. And then the second line, I wrote it all together. So a to the third times b to the negative second times negative a to the sixth times c to the seventh, all over b times c times b to the fourth times c to the third. And then you work that out, which will give you negative a to the ninth times b to the negative second times c to the seventh. And I got negative a because a times negative a, it will give you a negative a. And to the ninth because the 6 plus the 3 is 9. And then it goes over b to the fifth, which comes from the b by itself, and the b to the 4, times c to the fourth, which comes from the c by itself and the c to the 3. And then you go ahead and you work that problem out, simplify it down to negative a to the ninth times c to the third over b to the seventh. Then for my rational expression, I decided to use x squared minus 9 over x squared minus 6x. Multiply that by x squared minus 36 divided by x squared plus x minus 6, which then you factor those as much as possible. For the top one, I got x minus 3 times x plus 3 over x times x minus 6. Multiply those by x minus 6 over x plus 6 divided by x minus 2 times x plus 3. Down at the bottom, over here, I simply just brought everything down and put it together so that you can see what cancels out. So the x plus 3 on top and bottom cancel each other out, and the x minus 6 on top and bottom cancel each other out, and you're left with x minus 3 times x plus 6 over x times x minus 2. And then for my simplifying rational expressions, I did two examples. One is the square root of 9 times x to the second, or x squared, which is essentially the second one, 9 times x squared, and then you take the square root of 9 times the square root of x squared, which equals 3x. Then my second example, I did the fourth root of 16 times y to the 7th times x squared, and I broke it down so that I could get the fourth root of 16 times the fourth root of y to the 7th and the fourth root of x squared, which then I brought it down here. 16 is 2 to the 4th, and y, I split it into 2, so y to the 4th and y to the 3rd, and then x remains x to the 2. And so because the 4's that cancel out on the first one, it leaves you with 2, and then you have 4's that cancel out on the first y, which leaves you with just a y. So I have 2y, and then I carried over the remaining variables, which is y to the 3, x to the 2, and I put them under the square root.